Okay, so when you're doing trig proofs, okay, we've kind of started trig proofs, but we also had some that were multiple choice and some that were just transformations. Now we're getting more into proofs, but it's not new stuff. You've already actually been doing this. Okay, so to prove an equation is an identity, you have to start with one side and transform it to the other. This is what you did. However, now you get to go from either side. So real quick, let's look on the back. On the next page of your notes, like the back of the first page, basically. If you look at these, it doesn't say transform blah into blah. It says just prove these are equal. So you're going to get to start picking which side you want to work on. All right, so here's some helpful techniques. Pick the side you wish to work on and write it down. Okay, I'm also going to have you underline it. It's usually easiest to start with the more complicated side. It's almost always easier to start with the more complicated side. That may seem weird, but I'll explain it as we go through some problems. Okay, you've taken algebra 1, algebra 2. You know algebra. All right, so there's some things that we could do. If you have two terms, like if you had something plus something, and you're like, hey, I wish this was only one term, you need to add fractions, which means get a common denominator. This is what we left off on Friday, and I'm going to actually go back to that example here in a minute. Sometimes we need to factor. I'll explain what that looks like when we get to that type of example. We do have this thing called multiply by a clever form of 1. Now, we're not giving you problems where you have to do this, okay? But this is always an option. And we saw this when we rationalized, when we had over square root of 2 and we wanted to get rid of that. That's what we did there. All right, distributing, squaring, multiplying, all that stuff is the same stuff, and we've actually already been practicing it. All right, look for trig things to do. Okay, this is all your identities. Okay, when you see something like cosine squared, you need to be thinking, hey, that's an identity. That's a Pythagorean identity. You probably still don't have them memorized, but you're getting there, at least where they're more familiar than they were last week. Okay, what about cosine and secant? What happens to these two things when you multiply them together? They are reciprocals. Cosine is 1 over secant. So when you're multiplying these two things, they equal 1. And that's at the top of your blue card. And that's also like how we get when we multiply across. You need to recognize that. Today is not the day to have it all memorized, but you got to start recognizing identities. Okay, tangent x over cosine x. What is that the same as? That's a quotient identity because it's a fraction. Tangent, that's a tangent x. You need to start recognizing them. If we see squares, meaning something squared, we need to think Pythagorean. Okay? And we always want to look at the answer to make sure we're headed in the right direction. So here's another one of those trig hexagons, just for fun. Let's go ahead and fill it in. Now I'm not gonna talk. I'm gonna shut up. And if you need a hint, you can look up here. The shading is to help you know the Pythagorean triples. So sine squared plus cosine squared equals 1. That's one of the Pythagorean triples. Okay, down here, 1 plus cotangent squared equals the bottom cosecant squared. On this shaded one, tan squared plus 1 equals the bottom secant squared. You're welcome. And it only works on those three. Remember the reciprocals, you multiply diagonals, you get a 1. That's why we put a 1 in the middle. Okay, and also remember that tangent x and cotangent x, those are the ones where you can divide either direction. So all of the identities we've talked about, you can use this trig hexagon to help you with it. And if you're finding that it's not helping you, well, then you don't have to use it. It's just a strategy. Okay, so what I would like to do is to go back to an example that we had on Friday. Now, you may want to get those notes out, or you may just want to watch. And if you're watching this video, you may want to fast forward if you don't have this question. On Friday, though, we ended with this problem, and I want to show you, it was D right here, okay? And we wanted to transform tan x plus cotangent x. Now, this was the hardest one we did Friday, all right? And I asked you guys, what should we replace tangent x with? And you guys said secant x divided by cosecant x. And that is definitely something we could. Could I have picked maybe something else as well? What else could I have replaced tangent x with? Look on your card, look on your trig hexagon. Sine over cosine, okay? And at the time, we didn't know which one was going to help us. Same thing with cotangent x. We had cosine over sine. We also could have picked cosecant over secant. And what we found was, okay, we started to do things, and it just really wasn't getting any easier, okay? And so this is when, and this was good for us to go through, because watching me do a trig proof isn't even that easy. But doing them by yourself is even harder. So you're going to get stuck some of the time, and you need to know what to do when you get stuck. We were just, nothing was simplifying. Okay, so this is the time when you start erasing, and you go back and you say, okay, well, what else could I have used? So I didn't talk about this on Friday. However, I'm going to talk about it today, which is, when in doubt, change things to sines and cosines. So watch what I'm going to do here. I like this cosine x over sine x. I'm going to use it over here as well. Okay, tan x is sine x over cosine x. We're still going to get a common denominator, okay? So the common denominator is going to be your 2 denominators squared. So that's going to be cosine x times sine x. Cosine x times sine x. And what you do is you go, hey, what did I multiply the denominator by? So what did we in the first group multiply the denominator by? What was new? Sine. So we have to multiply the numerator by sine. So watch what I'm going to do here. Sine x times sine x. You can even see if I canceled out the sine x's, I would get what I started with. We don't want to do that. We don't want to undo our work. So look at the second group. What did I multiply the denominator by? It was sine, and now it's cosine sine. So you multiplied the denominator by cosine, so now multiply the numerator by cosine. Okay, once you have a common denominator, the whole reason we did this is so that we can get them into a single thing. Okay, same denominator, you can add the fractions. Now, what is sine x times sine x? How else could I write that? Like, how do you write x times x? You write it as x squared, right? So what we're going to do is we're going to write that as sine squared. Okay, what about cosine x times cosine x? Yeah. And when you start seeing squareds, you've got to be thinking identity. What is sine squared x plus cosine squared x? It's the main Pythagorean identity. It's a 1. Now, look at our answer. We want to get cosecant and secant. Do you see it? Maybe, maybe not. What is 1 divided by sine? Cosecant. And we can use that same 1 here. What's 1 divided by cosine? Secant. Isn't that what I was trying to prove? So that's how we know we did that one right. That's a harder one than some of the other ones we did. So we're going to keep practicing this stuff. So let's look at, let me say that. And let's look at today's Okay, so we're going to go through these 4 problems together. And I'm going to kind of explain the strategies. All right, now look at number 1. Find the equal sign. Which is the more complicated side? The left. So let's circle the left, or circle. Let's underline the left. And this is going to be our signal that we're starting with the left side. Okay, now I see a plus on the left. I don't see a plus on the right. So somehow I need to get just one thing. This could mean a common denominator, or it could mean something else algebraically. Like look at this group and this group. Are there any commonalities between these two things? They're both squared, and they both have a secant squared. So I'm going to factor out, like you don't need to write this down, but imagine we had something like this. 2x squared plus 6x, and you wanted to factor. You would factor out a 2, and you would factor out an x, and you would be left with x plus 3. You would write down what's left. Okay, that's what we're going to do here with trig. It's not that bad. It's really not that bad. Okay, so we're going to factor out secant squared, x. Now, when you factor something out and that was all there was, what are you left with? 1, right. Okay, we're going to write our plus sign. Now, if I factor out secant squared from the second group, okay, the secant squared's factored out. It's in front now. What's left? Tangent squared. Okay, now, I see squareds and I'm thinking Pythagorean identities. We already kind of said that. Okay, and I know that in the end, I want to only have secant. So what am I trying to get rid of? This 1 plus tangent squared. So either look at your trig hexagon or look at your blue formula chart, and I want you to see what does 1 plus tangent squared x equal, and we're going to replace that thing with something it equals. I want everybody looking. Secant squared. I want everybody to find that somewhere, either your notes or your blue card. Do you see where it says 1 plus tan squared x equals secant squared x? It's the Pythagorean identity. Now, we're pretty close. I only have secants now. By the way, algebraically, what is x squared times x squared? X to the 4th. It's like xx times xx. You just count them up. Okay? We're going to do something similar here with the trig. We're going to add them up. There's 4 of them. And isn't that what I was looking for? So I get to put a check, a smiley face. You can put the Latin QED that just says you did what you said you were going to do. It doesn't matter, but I think it's nice to put something to say, okay, we finished. And if you want to know what are you getting graded by, you're getting graded by your work. Not that you ended up with secant to the 4th. You knew that was going to happen.
Okay, when I saw that there's the equal sign on the right side, I thought we had to like transfer stuff over to each side.
Right. With trig proofs, we're going to work only on one side. We're going to start on one side, and we're going to end up with what we said it was equal to.
Whatever it's equal to is what we have.
Yes.
That's like true. We just have to prove it.
Yes. So like in number 2, this thing is true. What we're going to do is now prove it. That's why it's called a proof. We're going to start with the more complicated side. Okay? And we're going to do stuff to it. And in the end, our last equal sign should be what? Sine squared. So you could go ahead and write it if you wanted. Or you could wait. It doesn't matter. I don't know how much space this is going to take. So, algebraically, what's something I could easily do here? It's kind of backwards from what I did on the first problem.
Factor out the equation.
So this is already factored. So what?
Like,
Distribute.
yeah.
Yeah, I have a Band-Aid, but can you wait just a few minutes? Okay, that's fine. All right, cosine x times secant x. Here's what we're going to do. we're not going to get ahead of ourselves. We're going to just write it. Cosine x times secant x. You may already know what that equals. Let's just write it, and in the next step, we'll simplify it. Okay, minus cosine x times cosine x. Okay, don't get ahead of yourself. Don't try to do too much in one step. You're going to lose points, but you're also probably just going to get confused. All right, now think. Well, what is cosine times secant? Those two things are reciprocals. So what does that equal? 1. So let's replace that with a 1. All right, what about cosine x times cosine x? That's cosine squared x. And I see the squared and I'm thinking Pythagorean identities. I mean, it goes back to this. Let me kind of come back here. All right, now, this is not the exact identity, but I see a 1 minus cosine squared. Oops, there should be an x there, I guess. And that equals sine squared. You knew what? Here's the deal. You know it has to equal sine squared because I said it did. So that didn't take as much space as I thought it needed. I knew it had to get to sine squared. So use the end goal to kind of help you. All right. So let's look at number 3. What's different about number 3?
We now have a fraction.
We now have a fraction. For sure, we are starting on the left side, and that's pretty common. It could be that the right side is more complicated, and you can start on the right side if you want. All right, so when we have fractions, and what we want it to equal is not a fraction, you need to be thinking, get a common denominator. So the first thing's denominator is sine x cosine x. The second thing's denominator is just sine x. So I'm going to first write, I'm going to multiply, and I don't need to do sine squared, which some of you might be thinking, and if you're not thinking that, that's fine. But it's going to be sine cosine. Okay? You just need to have something that covers both items. Okay, so the first thing isn't changing at all. Okay, there was a sign in both denominators. That's okay. So the first thing doesn't change. So I just rewrite the 1. Now the second thing, what did I multiply the denominator by? Cosine. So I have to now multiply the numerator by cosine. Okay, I already had a cosine, and now multiply the numerator by cosine. You know you did this right when you could imagine crossing off the cosines, and what you have is what you had the step before. That's how you know you did this step correctly. Now, we don't want to do that. That undoes what we just did. Okay, I have the same denominator. Here's what I want you to do. Write one big fraction and rewrite that denominator, and now we get to just put the numerators in there. Are y'all okay with me going cosine times cosine is cosine squared x? Does that make sense? Now this doesn't equal tan x yet. However, what is 1 minus cosine squared? We just talked about this in the previous problem. What does that equal? Sine squared. And there comes a point when in a problem you're like, I know how this is going to work out. Does anybody see what we need to do next on this? Yep, I'm going to actually split this up into sine x times sine x. Don't be concerned about, don't be thinking, what's the least amount I can do to get full credit here? That's just not a good strategy. Just show your steps and you'll be fine. Okay, now, do you see anything that's going to simplify? The sign. This sine x and this sine x, when I divide them, I get a 1. And when you multiply by 1, you don't really have to write it. And what I have now is sine x divided by cosine x, which is tangent x. It's the quotient identity. One thing, and we're done with that one.
We're not starting something, I'm sorry.
One thing I do want to point out is look at your crossing out and look at mine. If someone were to walk in here, could they tell that what I crossed off was sine x? Yes, and that's important because I'm not going to be looking over your shoulder while you take this quiz. I'm only going to look at the end product. So here's what I don't want to see. Everybody watch up here and don't do this. I'm showing you what not to do. Don't do this. Because then I can't even tell what you had. Now I can assume, but I'm not going to assume. I don't want you to do that. I want you, when you cancel, to write it to where I could tell what was there. Because that's what I'm going to be doing. I'm going to be grading your work, not your final answer. Okay, everybody knows that the final answer is tan x. It has to be the other side. I wouldn't say half credit, but I will tell you, if you just wrote the first step or decided on the first step and then wrote the last step, that would get you 2 points out of maybe 8 or 10. That gets you some points. So don't leave any of these blank. Okay, last problem. Okay. When you see that something equals 1, you're like, don't ever start with the 1 side. That's tough to start with 1 because there's so many things that 1 equals. Start with the more complicated side. Okay. What is, when you do 1 divided by, what's a word that means the same thing as 1 divided by? It starts with an R. Reciprocal. So 1 divided by secant squared x, let's just ignore the squared for a moment. What's the reciprocal of 1 divided by secant? Cosine. So 1 divided by secant squared is cosine squared. Now, why would I be doing this problem this way instead of getting a common denominator?
So you just make it shorter?
Yeah, because what's going to happen next? What's the thing on the right side? 1 over cosecant squared x. What's that? Sine squared. And what happens when you add these two things? You get 1. And you're done. We could have done this problem where we got a common denominator. It would have worked out. It would have been like 4, 5, or 6 steps. Okay? So the more comfortable you are with the identities, the easier these problems become, because when I see this problem, I can see that, hey, this looks like the Pythagorean identity. And I've been doing this longer than you guys, so it's going to take some time. Mark.